So this morning in the seminar we started this lesson. We did a couple of examples. We didn't quite finish each of the examples. What I was focusing on and what I wanted to focus on was how you factor these quadratic trinomials. So, the focus this morning was on how to factor these quadratic trinomials, and what distinguishes them from the trinomials we were factoring yesterday to solve by factoring, to solve quadratic equations by factoring, is the fact that there's a coefficient in front of the quadratic term, there's a coefficient in front of the x squared term that's not 1. So we saw that it was not as simple as just saying, well, you know, if I can find two numbers that multiply to give b, my mistake. If I can find two numbers that multiply to give c and add to give b, then that's how I get the factor, or the factors, right? That was yesterday. Today it gets more complicated, and what we said was we're going to use trial and error. So when you're looking at factoring, I'm not sure why the question is gone here. It got deleted somehow. But the question was 6x squared plus 11x plus 3 equals 0 for a, correct? Is that right? Okay. So when we were looking at factoring this, what we said was that whatever you put here and here has to multiply to give your quadratic term, and whatever you put here and here has to multiply to give your constant term. Now be careful here. I know we just did this, but I'm spending time again because your day is busy and you may have forgotten that we were even here this morning. Who knows? You can't just go with that alone. You can't just put two things in the yellow slots that multiply to give 6x squared and two things in the blue slots that multiply to give 3. You have to FOIL it out and make sure that you're going to get the middle term of 11x. So that's what we did. We said, if I multiply 2x and 3x together, do I get 6x squared? Yes. If I multiply the 3 and the 1 together, do I get the 3? Of course. As I mentioned this morning, I don't think we really need to check those two products, because we put those things in those places precisely so that we would get 6x squared and 3. What you want to check, though, is your outer and inner. Your inner is 9x. Your outer is 2x. And these two terms add together to get 11x. So it's factored. Where we left off, however, was that you still have to take that 2x plus 3 and set it equal to 0, and the 3x plus 1 and set it equal to 0. So let's solve those now. If I solve 2x plus 3 equals 0, I'm going to move that out of the way. I would have to start by subtracting 3 from both sides and then dividing by 2 and getting negative 3 over 2. And if I take a look at 3x plus 1 equals 0, I would have to start by subtracting 1 from both sides and dividing by 3, and I get this. So the factoring, the stuff that is in brown on your screen, is simply the first step in solving the equation. Because we know, and we were just discussing this right at the end of the seminar this morning, that if the product of two things gives you 0, then if either of them are 0, you'll get 0. If A is 0, it doesn't matter what B is. 0 times b will be 0, and it makes the equation true. So we have to include both of those factors. You know, prior to today's work, if I said to you, solve this equation, you would only know how to solve it graphically. Well, let's solve it graphically. We're going to enter y equals 6x squared plus 11x plus 3. Probably try zoom standard first. That's usually the way to go. Notice that when you go zoom standard, there's an awful lot of wasted space on the left and the right of our parabola. Instead of going from negative 10 to 10, maybe I should go from negative 3 to 1. Again, I think you get this, but what I am getting at is that this stuff over here is wasted. There's no information there. This stuff over here is wasted. So to spread out our picture a little bit better, to see more detail, zoom standard goes from negative 10 to 10 in both dimensions. I'm going to go from, actually maybe I'll go negative 4 to 2. If we find the first x-intercept by going to our calculate menu and choosing 0, we can scroll to the left of it, hit enter, scroll to the right, hit enter, hit enter. You're going to get negative 1.5. We did talk about this, I think, somewhere. Don't worry about that 1e negative 12. Now, negative 1.5 is negative 3 over 2, which was one of our solutions. I'm not going to spend class time finding the other one on the calculator, but I want to point out something to you. When we were reviewing for the last exam, there were a couple of questions that asked you to find x-intercepts algebraically. And I said, don't worry about it, because you don't know how to do that yet. Now you do. If I said to you, I'm going to get rid of some stuff here. If I said to you, find the x-intercepts of this function, you can do it now, algebraically. Because you set y equal to 0, which means you're solving this equation, and now you know how to solve that equation on paper. Okay? Assuming it's factorable. They're not always factorable. When we take a look at this next one, again, briefly, go ahead. Are you saying, is it possible to have, are you saying you believe that since there's 2 x-intercepts, it's factorable? Okay, I just want to make sure. It turns out no. So I'll give you an example. Well, let's stick with this one. So I'm going to create, this is a great question. I'm glad you asked it. I'm going to create a different question here now. So just an imaginary question. Let's do and I just want to check something before I close this off. 121 minus 32. 121 minus 32. 4ac. 121 minus. Okay. So, if I gave you that equation and I said solve it algebraically. So everybody understand that the question being asked right now is, well, if there are 2 x-intercepts, isn't it automatically factorable? Right? Well, first of all, let's show that there are 2 x-intercepts here. Let's try this on our calculator. Let's graph y equals 2x squared plus 11x plus 4. I don't know why I entered it there. That's not very helpful. 2x squared plus 11x plus 4. And I'm going to go zoom standard. There we go. And let's even go so far. We have lots of time, and this is going to really connect well with what we're going to learn in the coming days. Let's actually find the x-intercepts. So we go to the Calculate menu and choose 0, which is option number 2. Go to the left of the first x-intercept, hit Enter. Scroll a bit to the right, hit Enter, and we get this number. Now, I don't know if you recall, but when I did this with the example that we were just working on, which was A, I immediately quit out of the graphing screen and I hit the X key to bring up X, right? And then I went Math, Enter, Enter. But my calculator can't do it. And you know what? No calculator can do it. The x-intercept here of that graph, or the solution to that equation, it has a value, but it's not a value that can be expressed as a fraction. And I'm not going to tell you how it can be expressed, because that will be maybe confusing. We will learn that later. But there is an x-intercept. And you could find the other x-intercept as well. I will tell you right now that you could sit here all day and try to factor this, and it's not going to work out. So even though there's two solutions, it's not factorable. Would you agree that if it is factorable, it must be 2x and x in the first two available positions to give 2x squared? Okay. And that means with the 4, it has to be 2 and 2. It can't be 2 and 2. Because if it's 2 and 2, then I have to put a 2 in each set of brackets, don't I? And I will then have created a common factor of 2 where 1 didn't exist before. So that's not possible. So if it is factorable, the 4 is not going to be 2 and 2. It must be 4 and 1. It has to be. Second. If it's 4 and 1, I can't put the 4 with the 2 for the same reason that I wouldn't put a 2 there. So it would have to be this. And I mean, I'm not doing a perfect job of convincing you, but I'm telling you, if you FOIL that out, you're not going to get 11x in the middle. And no matter what you do to get 2x squared with the product of these and to get 4 with the product of those, you will never get 11x. Go ahead. Okay, if there's one x-intercept, what's going to happen, and it seems to me we ran across one yesterday, I can't remember. Here is a case. We should be able to factor this. First of all, I cannot factor the 4 out, and I'm coming around to your question. I will answer it. I cannot factor the 4 out, so we are not dealing with something from yesterday where we just find the two numbers that multiply and add. We have to use a different method, and again, I'm teaching you the trial and error method. Remember what I told you this morning, and this is also for the people who weren't here this morning. What we put in the first two places, what we put in these two places has to multiply to give the 4x squared. And there has to be an x in each one. But it could be 4x and 1x, could be, or it could be 2x and 2x. More often than not, it's not 1 in the number. It's closer numbers. So I'm going to try 2x and 2x. And the numbers that I put here and here need to multiply to give 25. I've never seen, in 30 plus years of teaching math, 1 and 25 as being the numbers, ever. And that's not an exaggeration. It's never happened. Could it? Yeah. But I'm going to try 5 and 5. And if I FOIL this out, I'm not going to write this all down, but if I multiply 2x by 2x, I'll get 4x squared. If I multiply the 5 and the 5, I get 25. If I multiply my inner, I get 10x, and I multiply my outer and get 10x. That gives me 20x. Okay. Now, since we have two factors, I have to set each of them equal to 0 to solve the equation. But I hope it's clear that when I take the first factor and set it equal to 0 and solve it, and then I take the second factor and set it equal to 0 and solve it, I'll get the same number. And this is going to correspond, Ariana, to if I graphed the corresponding function, it would be 1x-intercept. The graph would come down and just touch the x-axis at negative 2.5, which is negative 5 over 2. Okay. So now this is getting tricky, and I'm pretty sure I know where your mind is at here. What if there is no x-intercepts? Okay. Well, I guess what I will tell you is this. If it's not factorable, this is really going to be tricky. If the thing is not factorable, there may or may not be solutions. If it's not factorable, there may be no solutions. If it's not factorable, there might be one solution. If it's not factorable, there might be two solutions. But the opposite, if there's no solutions, it cannot be factorable. This is really tricky. This is logic in mathematics. If there's no solutions, it's impossible to factor. But just because something is impossible to factor doesn't mean there aren't any solutions. So I don't think it's a road we want to really go down too deeply with, until we learn about something called the quadratic formula and the discriminant and some other things which are going to maybe bring it all together. The final thing I would say to you and everybody is, for now, everything's going to be factorable. For now. Okay? Later on, when things are not factorable, like I said, sometimes we will have solutions despite it being non-factorable. And sometimes when it's non-factorable, we won't have any solutions. It's a mess. Does that kind of help out? All right. So now getting back to this question. When we factored it, we got, actually maybe I will go here. Going back to this question, just to review how to factor it, and we have lots of time today. This is very important that you do well. Whatever goes here and here must multiply to give that, and whatever goes here and here must multiply to give this. And it seems to me that this was a very easy one. We didn't have many options to try. It's got to be 2x and x to give the 2x squared, and it must be 1 and 5. Was this the one where this morning I said, I'm just going to put the 1 first because that's the number I said first? Okay, so if for some reason you decided that you were going to swap the 1 and the 5, what you would do is you would say, well, 2x times x is 2x squared. That's good. 5 times 1 is 5. Your inner is 5x, and your outer product is 2x. And you would look here, this is your eyeball, you would look at these, and you would look up here, and you'd shrug your shoulders and say, well, I can't get 11x out of 2x and 5x. And that would mean that your guess, it's not really a guess, but putting the 5 and the 1 where we did, maybe we should try switching them around. And then if you FOIL it out, you get 11x. So that's a quick review of this morning. we still have to take each factor and set it equal to 0. I suspect many of you will look at 2x plus 1 equals 0 and say x is negative a half. But I'm going to write this anyway. We subtract 1 from both sides and divide by 2. And those are the solutions. So, like I said, that's a quick review of this morning. Let's take a look at C now. So, we want to get in the habit of asking if we can factor a greatest common factor out. We can't because that's not what I'm teaching you today. But can 3 be factored out of 13? No. So we're stuck with a trial and error. It's not as simple as just what two numbers multiply to give negative 10 and add to give negative 13. It doesn't work that way. So we put our two sets of brackets. Now this one is more tricky than A and B because there's some negatives involved. But it doesn't change the fact that we need to write 3x and x in the first two available openings because those are the only two options that will multiply to give 3x squared. When it comes to the 10, and you know me, even though we just started this today, I don't care about the negatives. We'll work out the negatives later. In terms of 10, what are some numbers that multiply to give 10? 1 times 10, 2 times 5. I am never going to try 1 times the number first if I have a different option. So I'm going to try 2 and 5. And I honestly don't know. I know that some of you can look at this and know exactly what the answer is. Okay? But I wrote 2 first and then 5, so I'm going to write them in that order. And I don't know that this is right. I can't help myself. I checked it as I was writing it down, and it works out. Okay? So let's imagine that I decided to do this. Okay? Let's just imagine here, which is going to be wrong, I think. I would say 3x times 2 is, 3x times x is 3x squared. That's good. I would say 5 times 2 is 10. That's good. And again, I'll clean up the negatives later. I just know that the numbers are right. One of these will have to be negative to get negative 10 for the product. And then I look at my inner product, which is 5x, and I look at my outer product, which is 6x, and I say to myself, one of these has to be negative, right? One of these has to be negative because either the 2 is negative or the 5 is negative, which makes one of these negative. It doesn't matter how I do it. If it's negative 6x, when I add 5x, I'm sure not going to get negative 13x. In other words, it doesn't work. So I swap them. Now, again, I know that we don't have to do this. If you followed along carefully, there's no need for us to say, does 3x times x give us 3x squared? Of course it does. That's why we wrote them there. But I'm going to say it anyway. Does the 2 times the 5 give us 10? Absolutely. What about my inner, which is 2x, and my outer, which is 15x? Listen to how I ask this question. Can these two things be combined to get negative 13? Yeah. They can be combined if the 15 is negative. That would give me negative 15x plus 2x, which is negative 13x. And now what I do is I reverse engineer it. I say, well, how do I get negative 15x? I follow those lines back and I say the only way it's going to be negative 15x is if the 5 is negative and the 2 is positive. Again, that's a 5-minute explanation of what's going on to get this. Hopefully it's a 1-minute process kind of in your head at some point. Because, and I just want to show this to you. I know I've shown something similar to you before. But I want to jump ahead in time here to Unit 6. which is called rational expressions and equations. And when you take a look at this question here that's consuming the screen right now, you're taking two fractions and dividing them. And your first step in doing this question, 2 units from now, is to factor everything completely. Okay? This is one question. It might be one multiple choice question on an exam. And I'm telling you that you have to factor 2x squared minus 5x minus 3 and 2x squared minus 11x plus 15 and 4x squared plus 4x plus 1. And you also have to factor 4x squared minus 8x minus 5. If it's taking you 3 minutes to factor each of those, that's 12 minutes of your exam, and you haven't even gotten to the content of this unit yet. That's the first step to factor everything. You cannot put off getting better and better at factoring because it will really hurt you later. And I'm not trying to intimidate you, I'm really not, or scare you by showing you this. I'm saying this is what you will be able to do if you can factor. And if you can't factor, you won't be able to. All right, I'm off my soapbox. We're done here. As far as I'm concerned, all of this may be work that you're writing down, but now we need to focus at the equation. We need to focus on the equation, which means that 3x plus 2 equals 0 and x minus 5 equals 0. So this will have a solution of x equals 5. We just add 5 to both sides. Here we subtract 2 from both sides and then divide by 3. So the two solutions are negative 2/3 and 5. What does that mean? It means if you put negative 2/3 in for x, the left side of this equation will give you 0. What else does it mean? If you graph this corresponding function, these will be your x-intercepts. One final one. So we're only doing a, b, c, and d. That's it. Then you got to practice. 21x squared minus 51x minus 36 because we need to zero the equation. It has to be equal to 0 because we're analyzing this by looking at the products equaling 0. If you have a times b equals 5, you can't figure out what a or b is. But if you have a times b equals 0, then a equals 0 or b equals 0. So I want everybody to take a look at this and see if you can figure out how we should start. How many of you, by a show of hands, have discovered that D is different than A, B, and C in some way? Good. For those of you that haven't, if you miss how it's different, you can still get the answer, but the road is very rough. How is it different, Luke? There's something different here in terms of how we're going to factor this that we didn't do in A and B and C because it didn't apply in A and B and C. Isaac? There's a common factor. And as I asked you to start working on this and I walked around the room, I saw a lot of you all of a sudden doing this. And that's fine, but you're working with bigger numbers. And since there's a common factor of 3, 3 divides into 21, 3 does divide into 51, 3 divides into 36. You always want to check to see if there's a common factor. Because if there's a common factor, let me pull the 3 out, which means factor the 3 out and explain why it's important. Then we get 7x squared minus, I believe it's 17. 17x minus 12. Now, we talked yesterday, and when we had similar problems, I asked, well, could we actually divide both sides by 3 to make the number smaller? And we said yes, but I said, I don't think we want to. We want to leave that 3 in there for a reason that's not important today. Just remember, don't get rid of it, okay? But what you're essentially doing is you've changed it from this equation to this equation. Right? Now, the 3 doesn't play a role. It's not going to give you a solution to the equation. I still want you to keep it there, though. So you're dealing with smaller numbers. Always look for a greatest common factor. Always when you're solving any kind of equation like this. So now, I can put 7x and x. Even this, my choices are very limited, right? It's 7x squared. It's got to be 7x and x. 12. 12 could be 1 and 12. It could be 6 and 2. It could be 4 and 3. Forgetting about negatives, which we polish up the negatives later. I'm not going to try 1 and 12. I'm not going to try 2 and 6. I'm going to start off with the numbers that are closer together, because for some reason that usually is the case. So I'm going to try 4 and 3. I said, just came out of my mouth, 4 and 3. I'm going to try 4x here and 3x there. And how many of you see almost immediately, I don't know why I wrote x's there, 4 and 3. How many of you see almost immediately that that's not a good move? It's not going to give us 17x. We have, oh wait, it will. It will give us 17x, won't it? This is 4x. This is 21x. Oh yeah, I was way off. It's going to give us 17x. If the 21x is negative, then we get negative 17x. So how do I get negative 21 out of that? I have to put the negative with the 3 and the positive with the 4. You'd be surprised how often with trial and error, if you use the numbers intelligently, like don't create a common factor if you don't have one, or don't use big numbers and small numbers, use numbers that are closer together. You'd be surprised how often your first guess is right. You know, life doesn't always go your way, so you can't take it to the bank that your first guess will always be right. But now what we do is say 7x plus 4 is equal to 0, and we say x minus 3 is equal to 0. Oh, x equals negative 4/3, sorry, negative 4/7. Must be a long day. X equals 3. Make sure you are all aware of how I'm getting negative 4/7. I'm subtracting 4 from both sides, which maybe on a written response we should probably show. Then the next step is to divide both sides by 7. Good? Any questions with D? So always look for a greatest common factor. The practice problem set is on page 6. I don't know the exact structure here. It doesn't matter. I suspect the first half of the problems probably don't have a greatest common factor. And then maybe you get down to around 21 or 22, and then you start to see a greatest common factor. But you always want to check for one anyway. What do I want you doing? Well, it's called practice because I want you practicing. I'm really getting away from, in math classes, the concept of homework. It's practice. If I know you're not doing well, my question to you is not have you done your homework, it's going to be how much practice did you do? That's my philosophy now. And if I see that you've only done 3 or 4 questions as practice and you're having difficulty, I'm here to help you, but part of me wants to say, come on, you got to put in the practice. You have about 35, 40 minutes here to work on these. Here's your motivation for practicing. We're going to have a quiz tomorrow on this. Maybe 3 or 4 of these equations. And I'm not going to give you like a half hour to do it either.